need to fill 2 up with the.
Oh my gosh, that was like perfect.
Wait, did you do 2?
2 what?
2 full droppers.
Of
Is that your
HCl.
3rd?
Yeah.
No, this is for the hydrochloric acid.
So you did two of those.
Yeah.
No, that's for the hydrochloric acid.
Yeah, 2 of those, right? So you don't do.
That's water, is it?
No.
That's
What?
hydrochloric acid.
I thought that was hydrochloric acid.
Yeah.
And this is hydrochloric acid, right?
Yes.
Okay.
You can.
So,
It looks like water.
just 2 of those, or do we
Two.
fill it up to like about
No,
like
that's about good. And just now put 1 piece of metal in there.
1 piece of metal?
1 piece of metal, 1 piece of magnesium.
That's what magnesium looks like?
It's a magnesium ribbon. So magnesium's not found alone in nature, so we extract it and then we put it as a ribbon.
Okay.
And then if you want to, you can pick it up and look what's happening.
There's bubbles. That
Bubbles forming.
What's happening to the metal.
means It's dissolving.
Yep. So you ever seen in movies where the metal gets eaten by acid?
Yeah.
And now you've seen it in real life.
That's awesome.
Oh,
Yeah, that's not smart either.
Oh, someone needs to light it. I'm good at this. Trust
No,
me.
I want to let Noah do it if you're recording.
Fine.
Do you want me to do that so you don't roast your phone? I'll do it.
I don't know how to use it.
Oh my god, Ethan. Okay, hold that.
There's the containers.
There we go. Put it in there, Noah. Nope. Burn, baby, burn. Throw it in there.
We just drop it in.
No, you hold it into it. Oh my gosh.
I guess it's CO2.
No, I mean it.
It popped.
Yeah.
Wait, Martin. It's supposed to go all the way down into the liquid?
Yeah. Just hold it.
Are we just supposed to stick it into the tube? Yep. Okay.
So it's
popped.
not CO2.
I'm not sure.
That would be CO2.
It's not CO2.
It extinguished the fire.
No, it made it ignite more.
We need to feel if it's
oxygen
colder.
or hydrogen.
It's colder now?
No, we need to see if it's changed. You're gonna have to touch what the chemical is, I believe. There's a this right here, Noah.
See the difference.
So yes, I know the fire went out. But
It's not.
what did you hear?
A pop.
What does that mean that it did?
Yeah.
I told you to blow stuff up.
Oh, okay.
So is that CO2?
No.
Yeah.
No.
Did it not release CO2? Is that not what it released? Okay.
What'd you predict? What'd you write on your paper?
Hydrogen.
Oh my gosh.
You can't say something. You just did the math.
I know it's on my
You
paper,
just
but
did
I'm
the
not looking
paper.
at my paper.
Right. That's
3 to 4 drops of each solution provided and put them in the test tube.
Well, there's none. There's none in this.
Yes, it's this and that. Maybe we should-
There's another. Oh wait, there's no solution in that either.
Yeah, that's just where you put the dropper.
Okay, Noah. Yeah, you need the camera.
I don't really.
Just hold it.
Just pop it up.
That should be good. Are we really pulling this in?
That's what I did.
Should we not ask
No.
Morgan?
You don't do that.
What?
You don't do that.
Oh,
You
crap.
just open it and take the drops out of this.
Oh, crap. I'm not going to tell
How
Martin.
many? Take a few drops.
Jesus Christ.
Alright, so which beaker are
3
we
to 4
using?
drops.
Okay.
Yes.
Okay, so let's see this other thing. Okay, well, I mean,
Wait, I already have it in.
in the thing?
Yeah.
Oh. My God.
3 to 4 of both.
That's 4.
One, two.
Okay. I did all 4 of them. Okay. So there's that.
There's
Wait, I think it's
precipitate,
formed.
right?
What is it?
It's precipitate.
Yeah, it's precipitated.
Change in color.
Changing color and precipitate. What is that? What did that make?
It looks like salt.
That's what it looks like. I'm sodium chloride. Heck yeah.
Tate and change.
Mark, did this make salt? Is that?
Started with salt.
Well, I know that much. But what did that make? Because it honestly kind of looks like a bundle of salt.
Well, you've got two ionic compounds. What have I said about ionic compounds?
This is silver.
They're always going to come out as a white
Okay,
powder,
gotcha.
and that's why we call them. I wouldn't touch your face if you're touching that bottle. So you got a white powder.
Right.
That means it's an ionic compound. We would call that a salt.
Okay.
Does that make sense?
So it can't.
But now you got to figure out using your solubility rules on page 6.
Right.
Which one's which? What's the liquid that's in there and what's the solid that's in there?
This is silver nitrate.
Silver chloride.
This is silver nitrate.
The solid in there is silver chloride. Right.
not CO2. How do you know?
Yeah.
That's
gotta be.
sodium chloride.
And the sodium nitrate is the liquid.
Oh yeah, sodium nitrate.
We can know even what's in that. We're done with it. It's silver chloride is the solid, and sodium nitrate is the.
We still need to do the splint test.
There is no splint test on this.
Oh.
Can you see?
That should be safe.
Yeah, until your phone blows up.
Well, I can already tell it's a color change.
2? Okay.
Oh. Yeah, it's a color change.
Alright, so
Color
you
change,
can
formation of the
Okay,
solids.
doesn't matter one of these three are used. Okay, you
That
get
creates-
this, you get drops out of here.
Yeah, which one is the solid for this?
Well, I think that's a precipitate.
Yeah, then put several drops like you fucking said.
Wait, yeah, it kind of has like a powdery look.
Put that, and this up, got it out, squeeze, put two or 4 drops.
Lead
of that
eye.
in. Watch it.
Yeah, there's some sort of precipitate inside of it. There has to be. It's leaving residue behind.
Well, where's the iodides on these ones? Oh, right there.
Oh, it says
Except for the
precipitate.
iodide. So the lead iodide is the precipitate.
Lead, iodide, what?
Lead iodide.
I didn't even see how you spell it.
Yeah, you put it quite a bit.
Okay. Let's.
It's fine, but you can actually see it there.
What is the atomic symbol for lead?
PB.
Okay. That's why I was thinking it once, but I couldn't remember.
If I do this,
I need to look at this better.
What, number 5?
Yeah. Okay, so there's one. Okay, I was looking at it wrong.
Okay.
There's one. 2 carbons.
H2, so
Yeah.
Okay.
or H2HC.
I don't know. So we're on 4 now, right?
Wait, we don't need to balance this. It's already balanced, right? Look, there's 1 CO3, both sides. There's 5 hydrogens on both sides.
Yeah, but
2 carbons.
This one?
2 oxygens, and 1 sodium.
but we have 2 H's. We're supposed to have 2 H's, but then that is also supposed to have a charge of 2, which would make that 2. But you can't just have, that's not how that works. I don't think. You can't just have it H2 and then make it H2 even though it's supposed to have a charge of 2.
Oh, it's
I think
still
it's gotta
balanced.
be. I think it's got to be like H2H or something. Because one of them has to be. Because you got to be crisscross.
Actually, that would still work though.
There's two H's.
Yeah, and that's what he says. And if you still do crisscross, it would still leave it with 2.
But you got to do the crisscross on those two H's. Those two
Yeah.
H's existed before the crisscross. So
No,
after
you
the crisscross,
switch the
they go in.
hydrogen with the CO3.
I thought we were switching sodium with hydrogen.
Yeah. It's H2. If we do that, that would be 7.
So it's
And then you would have to put a 2 here. Because then that would make that hydrogen 2. So it would have to be 3.
You're not making any sense here.
No,
And then that would have to be.
it makes sense, but it doesn't. I don't think it's how it's supposed to.
Which then makes that
Because if
6.
there's H8, you can't just put that as H2 because then you also have to, with crisscross, which would have to be 2. But then I don't think it just would be H4.
Well, you're
That's
making
what
it more
would do.
confusing. Well, we could ask him if.
But then if you just did H2 and then another H, that would only be 3.
You said the charge is 2, but there's 2 H's. Hold on. We can
Yeah,
ask
so
Mr.
like-
Martin.
So like if that wasn't a H2, it would be an H2 because the charge.
Yeah, but the
of-
H2 already existed.
That's the
Y'all
thing.
do, y'all do realize he's going to go over this sometime.
That's not. I don't think.
Me and Noah are kind of fighting over if we're going in the right direction. Because there's H2, then you got CO3, and if you do the crisscross, it's H2.
Yeah.
Other H.
So then everything else just balances itself out if you go over here and look.
Yeah, it's balanced, but it's not the final answer. It's close. You're on the right path.
Okay.
There's one more thing you got to do. And I'm gonna blow your mind when I tell you.
Oh, God.
All right, switch.
I'm just not going to freak out.
Should be the
about
last station. Let's go. Let's go. Let's go.
Wait, I forgot to turn the camera off. Test for this one?
What?
I'm doing the splint test for this one.
I'm not sure if I trust you on that.
Take a small scoop of powder and add it to the test tube.
And you did test.
That looks familiar.
That's not a small scoop.
Well, wait, hold on. Before we
What's-
do anything, a small scoop. Take
What's
a full
considered-
dropper of the liquid.
What's considered a small scoop?
Like
Add
that?
to the test tube.
Okay.
I think less than that. Like I would stop halfway.
I say just put it all in there if Martin says we can. I
And
mean,
then 4.
Wait, is that water?
No.
I think that's acid.
Well, yeah, because
Well,
it's
yeah,
going to be a
that's-
chemical reaction, right? But
I had to
it
think-
might be water, actually, though.
I had to think my decision through.
Okay.
It's this one.
I mean, is this sodium, sodium whatever? This is not water.
Yeah.
do whatever you want to try to blow it. Oh, there it goes.
Yeah.
Oh, it bubbled.
It bubbled. There went one. Bubbled. There was kind of a color change.
I don't think so. I think that's just bubbles.
Maybe. I can't tell.
Because I mean,
Okay.
Ethan, I'm
It
not
did
sure I
kind of
trust you
change.
with this.
You
but
can trust me.
Can I?
I'm a trustworthy man.
give it a couple seconds first. It's
Big
still-
claim.
Maybe it's even colder. You don't stick out, right? I think that's.
Extinguish. Wait, let's see.
But the our equation doesn't say it releases CO2.
What type of reaction is this? Well, this is a double.
That stinks.
Yeah, no.
It extinguished the fire.
Knowing what Martin said, I would say no on the second part of number 1.
I'm gonna leave it blank for now. So we're close on this equation.
But it didn't do. It's basically like the Mentos.
So this is, if you look on station 4, if someone will look at it, station 4, what kind of reaction this is going to be? This is going to be a decomposition reaction. Now, if you predicted that it was going to make H2 and O2, you're not wrong in your thinking, right? But it's not quite how it works out. What it's actually going to do is it's going to make oxygen gas and water. Does anyone know what H2O2 is?
No clue.
If you get a boo-boo, what was one of the things that
Hydrogen
your parents put on
peroxide.
there? Hydrogen peroxide. Now the idea, your parents probably told you when they put the hydrogen peroxide, this is going to what? This is going to clean your wound, right? Or kill the bacteria. It doesn't actually kill the bacteria. What it does is, the reason it hurts is because what happens is the hydrogen peroxide, when you put it on the wound, it does a rapid decomposition reaction, creating lots of oxygen gas, and that oxygen gas bubbles up and pushes any dirt or bacteria to the surface so then we can wipe it off. So it doesn't actually kill it, it just makes it where it cleans out the wound and pushes it out of the wound. So hydrogen peroxide does a decomposition reaction. If you've ever noticed about hydrogen peroxide, what color bottle does it always seem to come in? Brown or
Black.
Black. Why not clear? Why not clear? Everything else always seems to come in clear, right? Well, here's why. Decomposition of hydrogen peroxide can be triggered by the sunlight. So it could turn the hydrogen peroxide into what? Oxygen and water. Pretty much making it useless. Now this still happens. If you have an old bottle of hydrogen peroxide in your bathroom and it's been there for several years, it's no longer hydrogen peroxide. What is it now?
Oxygen and water.
It is now oxygen and water. And the oxygen will slowly leak out. It's not foolproof. It will slowly leak out of the bottle. So really you just got a bottle of what in there?
Water.
Water. Okay? Now, the hydrogen peroxide you guys have in your houses is what we call 3% hydrogen peroxide, meaning it's only 3% and the rest is water. Okay? This is 30% hydrogen peroxide. This stuff will literally dye your skin. It oxidizes your skin. Very dangerous. That's why I'm putting gloves on. And some of you were like, why don't we have gloves for the other things? I mean, technically you could have worn gloves, but you were never like touching it. What is going to happen, there is a possibility I have to touch it, and I don't want that on my hands. Okay? So what we're going to do is we're going to speed this up. What's one way we can speed up a reaction? What can we use?
A catalyst.
We can use a catalyst. And a catalyst does what? It lowers the activation energy. So what we're going to do, we're going to lower this. There's several ways you can do this. I'm just going to do the old school at-home way. I'll use yeast. I've taken yeast and I mix it with water. And what I'm going to do is, in theory, this is going to make a lot of bubbles, right? So what I've also added is I've added some Dawn dish soap, okay? And I put the yeast and the Dawn dish soap in the bottom of this Erlenmeyer flask. And what I'm going to do now is add the hydrogen peroxide. The yeast is going to act as a catalyst, so it's going to speed up this reaction. And what happens is you're going to see lots of bubbles. Now, if you do this the right way, if you do it just right, it will actually shoot into the air. This is called elephant toothpaste. All right, why it's called elephant toothpaste, you'll see in a second. You probably have seen Mark Rober do this and things of that nature. Okay, so are you guys ready?
Yeah.
Here we go. Okay, put it in, and since we got to do collision theory, what do we want to do?
Shake it.
I'm going to shake it a little bit, and we're going to watch what happens. Okay. And since we're using yeast, it's not going to be that explosive reaction that you guys want. Okay? But you're slowly starting to see what?
Bubbles forming.
Rising of bubbles. And I don't know how good the hydrogen peroxide is. It's been sitting in the back for a while. I need to add a little more.
We just like dump the whole bottle into it.
There we go. And so why it's called elephant toothpaste, as you'll see here, okay, it's got that same look as like toothpaste coming out of a tube, right? And it's going to keep going. Now, you should notice something else as it comes out, maybe, depending on what it is. Okay? All right, since none of you have gloves and it's hard to see it right now, you might see a little bit of steam rising. If you'll notice, I can confirm this, it is getting hot. It's getting warm. Okay? I have to go back to the test. My bad. Let's see. I got different catalysts I use. We try it every year. This is like the one reaction that is the bane of my existence. I hate it. Okay?
Now, what if we plug the top of it?
It will build up pressure and explode.
I say we just leave the room and
Yeah,
do that.
yeah. All right. So now for the big, right? Anti-communism, go America. So here's what we're gonna do. I know you stand over here to my right. Okay, so I know where you're at. So if you're wondering what this is called a fume hood. Now, when you do experiments in chemistry at college, you have to do all the experiments inside one of these. And so what the point of a fume hood is this, is you can lower this down. Okay? You can lower this down. So when you're doing experiments, if something goes wrong, what happens? It stays inside. It's also, if you hear it, I turned on the fan. It's called a fume hood because the whole point of it is it has a fan that sucks the gas out of here and throws it into the atmosphere. Now people are like, well, it dissipates, right? It's diluted. It would rather be out there than in here. Okay, so that's why you do it out here. That way, if there is any dangerous fumes you accidentally make, you're not going to be damaged by it. Okay, and yeah, you have to get good. Like you have to literally learn how to do it underneath. Okay, so sometimes you have to do that. Okay? Now I'm doing it because this is going to make fumes. So the first thing I'm going to do, I'm going to do a decomposition reaction. If you notice, the potassium chloride was in a metal pan, right, in plastic. That's because it reacts with air and it decomposes. Well, we don't want that to happen, but now we do. And to make this decomposition happen even faster, what am I now adding?
Heat.
Heat. One of the things we can do to speed up a reaction is to add what? Heat, temperature. So you're going to see, slowly but surely, it looks like it's just melting. It's not that it's melting, it's actually decomposing. It's turned into potassium chloride, and it's also turning into oxygen gas. It's hard to see, but there is some fumes that are being produced. Now that's the reason we're doing it, because the gas that's being made, if we did a split test, is oxygen gas. Well, what do we know about oxygen gas? What can you also do with oxygen gas?
Start a fire.
You can start a fire. You can do a combustion reaction as long as you have a, what? What do you need for combustion? You need oxygen gas and a hydrocarbon, right? Well, for us, our hydrocarbon, go ahead and switch out there, maybe for me. So we got the little switch. Okay, so now it's good and melted. Everyone see that liquid?
Yeah.
All right, so here's our hydrocarbon. Gummy bear is basically just pure sugar. Okay, so we declare you guilty of being delicious. May God have mercy on your soul.
Thank you.
Long live the gummy bears. All right. What signs of a chemical reaction do we have? What did we have? We got gas. We got formation of gas. We got smoke. What else? What did you see during the reaction?
Color change.
Color change. Lots of light. Light is color. So seeing a bright light, that is considered a color change. What else? If I were to touch this, which I'm not going to, what do you think it probably feels like?
Hot.
Very hot. Very, very hot. No precipitate, but that's 3 of the 4. And that, ladies and gentlemen, is what we call a coupled reaction. We did one reaction to then do another reaction. This is actually a lot what happens in the real world. This is what happens in your body a lot. One reaction leads to another reaction, which leads to another reaction. We call them coupled reactions. Okay? So, long live the gummy bear. Any questions?